So today we're talking about lesson 2.12, and your learning goal today is to be able to multiply decimals and whole numbers. Basically, we are going to have one more chance for you to really practice what we've been working on both on Monday and Tuesday. On Monday we learned to multiply decimals by renaming them, right, as however many tenths or hundredths. And then yesterday we learned how to multiply by 100 and then divide by 100 to put the decimal place back. Give me a thumbs up if that is something you remember learning. Everyone should have their thumbs up. Good. So today we're going to do a little bit more practice with this and really make sure we're all feeling confident and on track. Okay? But first let's talk about the problem of the day. Today I want to first start off by talking about multiplication. What is multiplication? Like, why do we do multiplication? Like, what is the point of multiplication? Why does it what is it used for? Drew?
If you have a lot of groups or something, you don't want to count them by like 1, 2, like 100 cups, and they're like 100 stacks of those 100 cups. And
Sure.
You don't want to count one.
Each one. So multiplication is the same as doing repeated addition. It's a quicker way to do repeated addition, right? We could also think of multiplication as making copies of something. If I have 4 people here at this table group and I want to have 7 copies of this table group, how many people would there be altogether?
28.
We'd do 4 times 7. We'd make 7 copies of these 4 people, right? So we can think of multiplication as making copies, duplicating something, right? Or we can think of it as repeated addition. We could do 4 plus 4 plus 4 plus 4 plus 4 plus 4 7 times, or we could do 4 times 7. Yes? Now, let's think about that for a second. So then, in multiplication problems, there's factors, as we know. These are called the factors. The numbers you multiply are called the factors. And then there's a product, which is the answer, right? So let's look at these factors, the factors of 2 and 3. When I multiply 2 times 3, what is the product? 6. Okay. So right here I'm making 3 copies of 2, or could I also think of it as making 2 copies of 3? Yeah. Okay. For the second problem there, I have 2.31 times 22. Those numbers are called the factors. And so I can think of this, if I want to put it into word form, I could say 22 2.31s, right? Or I could say 2.31 copies of what? 22. Go ahead and solve that in your notebook really quickly. You know how to multiply this. What's 2.31 times 2? 20. Okay, let's look at that first problem. 2 times 3 equals 6. How does the product of 6 compare to the factors? How does 6 compare to the factor of 2? Is it bigger or smaller? Huh? Bigger. Okay. How does it compare to the factor of 3? Is it bigger or smaller? So the product here is bigger than both of the factors, isn't it? What about the second problem? 50.82. 50 and 82 hundredths. Is that bigger than the first factor? Yeah. Is it also bigger than the second factor? Yeah. So this product is bigger than both of the factors. Do we expect, without even solving this problem, 2.31 times 221, do we expect that product to be bigger or smaller than those factors? Bigger. Bigger? Why is that? How come when we multiply these factors, the product is bigger than the factors? Sonia?
Because you're making copies of those factors.
Ah.
And the amount of the things in those copies are going to, if you add them up, they're going to be bigger than the factors.
Right. So let's take a look at this problem. I did 2 copies of 3. So if I have 2 copies of 3, will I have more or less than 3?
No.
Right? If I copy something, do I have more of it?
Yeah.
Or let's think of it the other way around. If I make 3 copies of 2, will it be bigger or smaller than 2? Okay. Here, I'm making 2.31 copies of 22. So is that going to be more or less than 22? More, right? So the product is bigger. What if I go the other way around? If I make 22 copies of the number 2.31, will I have more or less than 2.31? More. I'll have way more. 22 times more, right? What about this third one here? If I'm making 221 copies of the number 2.31, is that product going to be bigger or smaller than 2.31? Bigger. Way bigger. 221 times bigger, right? What about over here? If I have 2.31 times 221, I'm making 2.31 copies of 221. So will that be bigger or smaller? Bigger. About 2 times bigger, right? Okay. Okay. 495 copies of 1.11. Will the product be bigger than 1.11 or smaller? Bigger, right? Because how many times bigger will it be? Okay. What about if I think about it the other way? If I'm making 1.11 copies of 495, is that going to be bigger or smaller than 495? Bigger. Okay. So in this case, the product will be bigger than both factors. What about this second problem here? 0.98 copies of 495, or we can think of it as 495 copies of 0.98. Talk to your table group. Will it be bigger than this factor? Will it be bigger than this factor? Go ahead and talk. I can think of the second equation as being 98 hundredths of this number, of 495. So am I making a whole copy of 495? Is 0.98, is that bigger or smaller than 1? So am I taking a full copy of 495? I'm only making part of it, huh? So is my product going to be bigger or smaller than 495? Interesting. So my product's going to be smaller than 495. Okay, what if we think about it the other way around? I'm making 495 copies of 98 hundredths. So is it going to be bigger or smaller than 98 hundredths? Right, because I'm copying it 495 times. So this product we know is going to be smaller than the factor of 495, but bigger than the factor of what? 98 hundredths. If I take less than a full copy of Kevin, would we have all of Kevin here? No. If I only copy Kevin, but only take 98 hundredths of him, will all of him be here? No. No. But if I take Aditya and make 495 copies of Aditya, will we have more than the original Aditya? Yes. Okay. So oftentimes we learn that multiplication means that the answer always gets bigger. Is that the case? Okay. Let's take a look at this next one. 102 and 64 hundredths times 495. Will the answer be bigger or smaller than the first factor? Bigger. Will the answer be bigger or smaller than the second factor? Bigger. Right, because they're both of those factors are larger than what magic number? 1. We're making more than one copy of those factors. What about this next one? 0.25 times 51. Am I taking, is it going to be bigger or smaller than 25 hundredths? Bigger. 51 times bigger, yeah. Is it going to be bigger or smaller than 51? Smaller. Because this factor here is less than 1, we're not making a full copy of 51. Does that make sense? Mm-hmm. We're actually only taking 1/4 of 51, right? It would be like if I took Itai and I only wanted to copy him 0.25 times. Will we have more or less than the original Itai? Less. So of course we're not going to do that. Okay, one final one to check in with our understanding. Would our product for this one be bigger or smaller than this first factor? Bigger, because 84 is more than 1. Would it be bigger or smaller than the second factor?